right, we're going to pick up with day 2, activity 3.3, vertical dilations and vertical translations of functions. Let's consider more transformations of the basic function f of x equals x. Number 1, describe the transformation performed on f of x to produce g of x, then graph g of x. Write the function equation in general form. All right, so for part A, g of x tells me it's 2 times f of x plus 7. So what we're going to do is we're going to take this original f of x, multiply it by 2, and then add 7. So remember, f of x equals x. So if I multiply 2 times f of x, then that's going to give me 2x. Add 7, there's my new function. So what that means is I'm going to, instead of starting at the origin, I'm going up 7 and starting at 7. And instead of going up 1 to the right 1, up 1 to the right 1 for my original slope, my slope has changed to 2 over 1. Can think about slope as being a fraction. And from 7, I'm going up 2 to the right 1, up 2 to the right 1. And you can go in the other direction, down 2 to the left 1, down 2 to the left 1. And there is g of x. Let's do that same process for b. F of x equals x, and it's graphed here. I'm going to multiply x times 3, so g of x is going to become 3x, and then I'm going to take away 1. So there I'm going to go down 1 on the y-axis. That's going to be my slope-intercept. That's where it crosses the y-axis. My slope has changed to 3. Think about slope as being 3 over 1. So I'm going to go up 3 to the right 1, up 3 to the right 1. You can go in the other direction. Go down 3 and to the left 1. And there is your function g of x. Let's keep on going. Part C. We're going to multiply 1/3 times x. So g of x is going to be 1/3 x. So 1/3 is going to be my slope. Add 2. So I'm going to start at 2 on the y-axis. And I'm going to go up 1 to the right 3. Up 1 to the right 3. Down 1 to the left 3. And there is my function g of x. And there is my equation. Part D, I'm going to have 1/2 x. So g of x equals 1/2 x minus 3. So I'm going to start at -3 on my y-axis. And I'm going to go up 1 to the right 2, up 1 to the right 2. Go in the other direction, down 1 to the left 2, down 1 to the left 2. And there is my function of g of x. So you can see how that transformation has occurred. Let's keep exploring. For E, I'm going to multiply by -1. So g of x is going to be -1x minus 4. So I'm going to start at -4 and think of that -1 as a fraction. Down 1, right 1, down 1, right 1, down 1, right 1. Go in the other direction. So there's g of x, and there's g of x. Here I'm multiplying -2/3. So g of x is going to be -2/3. And you may want to think about keeping that negative sign in the numerator's position. and then adding 5. So we're going to start at 5 on the y-axis because that is my y-intercept. And then I'm going to go down 2 because that's a negative 2. 1, 2, and right 3. Down 2, 1, 2, 3. Down 2, 1, 2, 3. Go in the other direction, up 2, 1, 2, 3. And there's g of x. When a function is both translated and stretched vertically, the resulting function can be written in the form a times f of x plus d, where d represents the vertical translation of f of x, and a represents the vertical dilation of f of x. Consider the function g of x equals a times f of x plus d. How does changing the a value affect the slope of the function and the y-intercept of the function? Changing the a value does not affect the y-intercept. The a value affects the slope. Part B. How does changing the d value affect the slope of the function and the y-intercept? The d value does not change the slope or affect the slope, but it affects the y-intercept. Activity 3.4. Applying linear function transformations. Your company is developing a new video game for kids, which involves scoring points by shooting targets with a cannon. The cannon starts at the origin of the coordinate system as shown. By default, it shoots along f of x equals x. Players can move the cannon up and down the y-axis and also change the angle of the cannon. When a player shoots the cannon, the game program determines the values of a and d for the linear function. If the target is on the line, the program will show an animation of the cannonball hitting the target. Oh, look at that fun game. Number 1, test the program. Determine values for a and d for 4 linear functions that should hit the targets shown. So there's lots of options that you can do here to hit the target. Let's just try to hit one target. So if I was going to pick a target, I'll pick this guy right here. And I think about this one being as an ordered pair. And there's lots of ways that you can think about this. This is just what came to my mind. I'm going to say that that's 1 and negative 3. That's its location. It's almost like Battleship, right? And I want to hit this little sea creature with a cannon, which is weird in itself, but it's a video game, right? And let's say that I keep the cannon on the origin, and I use f of x equals x, which is really y equals mx plus b. And they're saying that m is your a and b is your d. So I know that this is going to stay at the origin. It could move, but I'm going to say that it stays at the origin. So I've got y equals ax, or f of x equals a times x plus 0. So I know that d is 0. So I'm basically trying to figure out what the slope is. So let's plug in this ordered pair. So -3 for your y, m for your slope, or a, whatever you choose to use, and then 1 for your x. Solve for m or a. Divide by 1. That doesn't change anything, so my slope is -3. So that is your a. So we can say that my a is -3 in this situation, and d is going to stay at the origin. So if I go down 3, 1, 2, 3, and right 1, that will hit my sea creature, and I could say, you sank my battleship. That's what comes to mind. So that's just one situation there. And then for number 2, identify the domain on which each graph hits the target. Identify the domain on which each graph hits the target. Well, for the upper left target in quadrant 2, the domain for the linear function is the set of numbers less than or equal to 0. So for quadrant 2, we have x is less than or equal to 0. For the lower quadrant, even quadrant 1, all of these are basically going to be x is less than or equal to 0. Let's keep going. The game developer is also testing 2 other versions of the game with different abilities for the cannon. Version B, the cannon can only shoot along the line parallel to f of x equals x, or f of x equals -x. It can move up and down the y-axis. The cannon can change angles, but it remains fixed on the origin. Determine the values for a and d along with their corresponding domains for the 4 linear functions that can hit the target in each version of the game. Show your work. Okay, so let's look at version B. Let's say that a is going to be -1, so remember we said that was our slope, and d was going to be 2 for our y-intercept. So that means my slope is -1 and my y-intercept is 2. So if I start at 2 on my y-axis, and that's where the cannon would be, I would go down 1 to the right 1, down 1 to the right 1, down 1 to the right. But if I go in the other direction, up 1 to the left 1, up 1 to the left 1, up 1 to the left 1, and I think that would be a hit. You sank my sea creature. And notice that I have a negative slope, and that's what it means by having -x. Let's look at version C. And there's lots of examples that you could have here. Okay, so for version C, this is just one situation where you can have -1/5 for your slope and 0 for your y-intercept. So we're going to keep our cannon right there in the middle. And we're going to go down 1 to the right 5. 1, 2, 3, 4, 5. In the other direction, up 1. 1, 2, 3, 4, 5. So it looks like we might hit that one right there. Might be off just a little bit. Maybe we'll just clip one of his legs. Let's look at number 3. What does it say? Determine the values for a and d along with their corresponding domains for the 4 linear functions that can hit the targets in each version of the game. So we did an example for each, and your domain is still x. Well, sometimes it'll be x is less than or equal to 0, or x is greater than or equal to 0. Domain are your x values. Let's talk the talk. Function matching. Always remember that a function is where your x values do not repeat. The graph shows the linear function f of x in 4 transformations. So we need to match those transformations. Let's see what we have here first. Let's take k of x. It's kind of sticking out there. Notice how it crosses at 8 on the y-axis. So I'm going to be looking for 8 right there. And I notice that its slope would be 1. So I would be going up 1 to the right 1, up 1 to the right 1. So that seems to work. And let's take JK. Or not JK, just kidding. Let's take J of X, which is -7, is your y-intercept. So here's -7. Slope again is 1. So that looks like that works. And let's see, I guess I should label these a little bit better. Just trying to use color. So there's J of X. And my blue is K of X. Grab another color, maybe green. And let's see what this one is. H of X definitely goes through the origin. We need to figure out what the slope is though. So I can start at the origin and I'm going up 2. Notice this crosses in the corner. Up 2, right 1, up 2, right 1. So that's a slope of 2. Y-intercept is 0, but it has a slope of 2. So that is H of X. And I'm going to take a wild guess on the last one. 1/3 of X. So 1/3, it's a fraction. It's a small number. So you're going to have a small rate. So let's see if that's G of X. So we're starting at the origin again, and we're going up 1 to the right 3 places. Yep, that's G of X. So there my slope is 1/3, and my y-intercept is 0. Match each transformed graph to one transformation in the table. Explain your reasoning. Well, I think we did that. That concludes today's lesson.